Record. Good. Okay. So today we're going to talk about where gluten comes from, how it's formed, why it's so important, the different types of flours that you might be working with in the bake shop, and if we have time, then we'll talk a little bit about yeast. Okay. So basically, this is like catch up of all the stuff that like I've been kind of mentioning here and there during demos, but we haven't actually done an official lecture on so far. Okay. So where does flour come from? It comes from a plant. The wheat kernel, I'm sorry, I answered my own question. There you go, flour comes from the wheat kernel, big surprise, okay? Okay, so flour comes from a plant called the wheat plant or wheatgrass, okay? So I'm sure you guys have all seen this where you pass like, or you've seen in movies where you've got like your field and then you have grass kind of like growing out like this, and at the end of it there's these like kind of things like that. That's the wheat stalk. There's a bunch of them. Inside here are little berries that are about the size of a fingernail. Inside of them is where flour comes from. The wheat kernel. Each individual wheat kernel comes from one of these little berries that's inside of the wheat plant, okay? So I'm gonna draw a bigger version so I'm gonna draw a big version of the wheat kernel. So one of these little berries over here. This should look familiar from your text, okay? So this is a giant version, and pretend we're like cutting like a cake slice out of it, okay? So we're kind of like cutting a little triangular piece. So the wheat kernel is divided into 3 sections. Does anyone know what they're called? Endosperm? Endosperm. So your endosperm is your biggest section. Okay, so your endosperm is your biggest section, like on the inside. Does anyone know what the bottom section is? Nope. Good idea though. Anyone at home? Think of what do healthy people put in their smoothies? Aside from protein.
Protein.
How about germ? Wheat germ? Does that sound familiar to anyone?
It does.
Germ is on the bottom. And the outside is called the bran. Okay, so I'll type it into the chat. Okay, so you have your endosperm, germ, and bran.
Oh, ADR.
I said before you guys came, I was trained by European chefs, so a lot of things that I spell are the European way.
Oh, so that's cool. Good.
So I think that the American way is AL.
Okay, good. Okay, got it. I like that.
All right, so these are your 3 sections of your wheat kernel. All right, your wheat kernel comes from a plant, okay? The wheat plant. And now we're going to talk about the different functions of these 3 items. Okay, so let me get my different colored markers out. Hello, Miss Nunes.
Hi, I'm doing a around here, so don't mind.
Ignore the man behind the curtain. Okay, so why don't we let's name some flours that you guys have worked with in the bake shop so far. What's one flour that you've seen?
Bread flour.
Bread flour. What's another? All-purpose. Semolina. Cake flour. There's one more that I'm looking for in particular that you may have seen, but you may not have worked with. Oh, high gluten. All right, there's another one that I'm looking for.
Whole wheat? Did you use any?
Okay, there's two more that I'm looking for. Pastry flour, that's what I was looking for. Whole wheat and pastry. Okay, so on one of the videos that you guys watched, did I start recording this? I did, right? Okay, good. On one of the videos that you guys watched from, I think it was the San Francisco Baking Institute, you saw different flour comparisons and how they hydrate differently, and the difference in like their textures, and when you squeeze them with your hand, how you can tell the difference between them.
Yeah.
Now, all of these flours all come from the wheat kernel. Semolina we're going to ignore for now because it comes from a different plant. So for right now, concentrate on high gluten, bread, all-purpose pastry cake, and whole wheat. All of these flours all come from, okay, so all of these flours all come from the endosperm. The difference in these flours is the protein content, okay? So let's go back to the wheat kernel. Your endosperm contains your two gluten proteins. So your endosperm contains protein. Your bran, anyone want to give bran a shot? What do old people eat?
Fiber.
Why?
Why do we eat it, or why is it in the bran?
Why do we eat it?
Because your body can't digest it, so it just allows your body to function better.
Makes your pipes move a little better, huh? Cleans you out. And you're good, Brittany, better digestion. And your germ has your healthy fats, okay, healthy is a key word in there, healthy fat and vitamins A, C, and E. So in the extraction industry or the processing industry, they're able to remove all of these little wheat berries and they grind them down, they refine them to get these little hard little berries ground down into flour. If you process the entire wheat kernel, it makes whole wheat flour. That's why whole wheat flour has a lot more texture to it, and it has a slightly different color. It has a browner color because it contains everything, the whole wheat kernel. It has the endosperm, the germ, and the bran. The germ and the bran are both like brown in color, which is why the flour is brown. The bran is the like coating on the outside. That's like the protective shell of the entire outside. Okay, so remember, this is kind of like a cake slice. Like your bran would almost be like the icing on the outside of the cake. Okay. Now, all of these other flours are how we process or how we make white flour. So all of these flours are processed without the bran and the germ. So they're able to go into each wheat kernel that's like the size of my pinky nail, really, really small. They're able to bust these suckers open and only process the endosperm. So all of these flours only have the endosperm. No germ, no bran. Which is why they're white, because they don't have the brown coating of the brown on the outside and the germ from the very bottom. The germ is like if you were to try to regrow a wheat kernel, the germ is where it would sprout from. This is where it would germinate. That's where that term germinate comes from. It's why it's called the germ. Okay, so let me, gluten is created by 4 things you need to make gluten. You need your 2 gluten proteins found in the endosperm. Those proteins are called glutenin, and I'll type it into the chat for those of you at home. Glutenin. The second protein is gliadin. Okay, so to make gluten, you need your 2 proteins from the endosperm plus moisture plus mixing. So if you go back to your straight dough mixing method, there's a reason why we mix on first speed for 3 minutes, second speed for 8 minutes, and then third speed for 30 seconds. And those changes, you can see the visual changes that your dough is going through as it passes through all those stages. Pick up, clean up, and what's the last stage? Gluten development. That's where you have your 2 proteins, you've added moisture in the form of either water or milk, and you're mixing your straight dough mixing method. All 4 of these things form what's called your gluten matrix, which was what I showed you guys when we pulled the gluten window. You could see those 2 proteins all linked up, okay? So really what's happening is you have your, let's pretend my hands are the 2 gluten proteins. So you have your glutenin and you have your gliadin. They're just hanging out in the flour, and then you add moisture and you add mixing. On first speed, they link up very loose like this. Get closer to the camera, okay? They link up very loosely. The more you mix, the tighter it gets, the tighter it gets, the tighter it gets, the tighter it gets. By the time you get to third speed, those 2 proteins are really linked up and strong like that. When they get to this, then it's strong enough for you guys to shape it. And that's when you start to get that smooth kind of looking dough when you pull it out of the bowl. Okay, so when you're looking at it and it looks like really, really lumpy, that's when your 2 proteins are like barely linked up. So you need your moisture and you need mixing. You need both of them. Now, different types of flours, like rye flour, don't have gliadin. When they grow, they're missing a protein. Therefore, rye flour does not produce gluten, because you need both proteins. So that's why rye flour is really difficult to make. All of the rules that you know about mixing bread. You're gonna mix it for 3 minutes on first speed, 8 minutes on second speed, and 30 seconds on third speed. And then you're gonna give it an hour bulk fermentation. Then all of those rules go out the window when you're working with rye bread. Rye berries grow in like cold, damp places. So Europe is very cold and damp. That's where the rye berry grows. And all of like the European chefs They all know how to work with rye because that's what was available to them. But all of those bakers are dying, and they never passed on all of those tricks and secrets of handling. Rye bread is really sticky to work with, like super, super sticky. So you need to kind of, it's like an art to learn how to work with it and how to mix it and how to actually get it to work for you. So when you go to the grocery store and you buy a loaf of rye bread, that's not real rye bread. It's white bread that they add flavoring into.
Really?
Yeah. If you look at the back of the package, it will say enriched white flour will probably be the first ingredient, and then like a little bit of rye flour.
But what about like a rye bread? Like ShopRite has a baked bread and combined.
Depends on who it came from. If it came from like Rockland Bakery, it's still white bread. If it came from like Balthazar Bakery, it might be a real rye. In order for it to be considered a true rye, it has to have, in terms of baker percentage, 30% rye flour. So the more rye flour you add, the more difficult it is to work with because you don't have the gluten. You don't have that gluten matrix that's forming because you're missing one of the gluten proteins. So rye flour and pumpernickel bread, same thing. Pumpernickel is just a darker rye. It is not milled as much, and it bakes for much longer, which gives the pumpernickel that darker color. Thank you. I was going to say texture. That's not right. Yep, I know. Ashley, isn't that crazy? So everyone always says like, oh, eat a darker bread. It's better for you, right? Like I'm sure you've heard that. Oh, I want to be a little bit healthy. I'm going to start eating pumpernickel bread or rye bread, because it's better for you than white bread. If you're getting it from the grocery store, you're just putting white bread into your system. But why is white bread so bad for you? The reason it's so bad for you is because all of these white flours, so all the breads that we're making in this class that only have bread flour in it, only come from the endosperm. So you're missing your bran and your germ. Each of these, protein, fiber, healthy fats, and vitamins, these all help your body function in a certain way. They all work together, right? Your protein helps you build muscle. The fiber helps you digest. Your healthy fat helps your hair and your skin grow. Your vitamins help your fingernails grow. They all build on each other to give you a healthy body. So when you remove the fiber, the healthy fat, and the vitamins, all you have here are protein and starches. What do starches do in your body? Turn to sugar. And what does sugar do to your body? It stores fat, exactly. So that's why white bread is so bad for you. You don't have all these other things, right? It's kind of like the difference between drinking apple juice and eating an apple. Which one's healthier for you?
Yeah.
Eating the apple. Why? Fiber. It has the fiber in it, so your body is working to gain those calories. Right? You're chewing, you're digesting, your gut is working to receive that sugar. It has to process it to get it. When you're drinking apple juice, you might as well just take like corn syrup and inject it into your bloodstream. Right? You're not working to receive the calories, right? And calories translate to energy, right? The more you eat, the more energy you have, except when you're just like injecting sugar straight into your bloodstream. I know Nezarite bread is so good. Right? But the reason it's so good is because you're getting sugar, you're getting the starches, right? When we're tired, what do we crave? You crave things that your body doesn't have to work to process, right? So all of these white flours all have a different protein content, okay? So we're going to switch gears and we're going to go over how they process all of these white flours and what the gluten percentage is. Yes. So now they have like really modern refinement techniques, but back in the day they used to just have these two giant stones that they used to carve grooves into, and they would put all the dried berries from the wheat plant onto the bottom stone, and then the top one would come and they would grind in opposite directions, and they would have these little like tubes almost kind of like carved out in the stone, so that as the stone is grinding, all of the flour that's falling into the tubes then falls out into a big like wooden bin. That would then be the flour. But back in the day, they didn't have the modern technology to separate out the bran, the endosperm, and the germ. So essentially they were only making whole wheat flour, which is better for you because you're getting the fiber, the germ, the healthy fat, everything all working together. So back then, not only were they were harvesting their fields, right? So they're working to get the wheat berries. Now they're doing manual labor to process, right? I mean, they didn't have machines to do this until the Industrial Revolution. So they had like bars that came out from this, like they would be like the big stone, and then there would be bars on it that people would have to push to rotate the stone. So now they're working to create their flour, and you guys know that bread work is a lot of like, right, hand mixing. They didn't have machines to mix it, so they're hand mixing just to create a bread that doesn't just have white flour in it. That's why they weren't fat. Yes? Say it again. Cups, what kind of cups? No, I have quart containers. Yeah, help yourself.
It sounds like more of a random lecture.
Yeah. You want to get up here and do it? All right, so your flours, the difference in them are protein content. Okay, so let's start with bread flour because that's what you guys have been working with. So bread flour is about a 12% protein. All-purpose flour is 10%.
Thank you, Cheryl.
You're welcome. Pastry flour is 8%. Cake flour is about a 4%. High gluten is about 15%. And whole wheat is about a 13%. So our technology now allows us to take the endosperm, separate it off from the germ and the bran. The bran gets sold off to cereal companies to make Raisin Bran cereal and Raisin Bran Crunch and all that good stuff. The germ gets sold off to health food companies. I think I have the germ in the dry storage. I'll show you guys what it looks like. But that gets sold off and health food companies use it. They put it in granola. They put it in all kinds of healthy, like add this to your smoothies and your health is going to be great kind of things. And within the endosperm, they can process it to extract only a portion of it to create these different protein contents. So all of these white flours, high gluten bread, all-purpose pastry and cake, no, high gluten bread, pastry and cake, all come from different portions of the endosperm. So your high gluten flour is the entire endosperm, the whole thing, all the way to the outside, closest to the bran, the whole thing. Your bread flour comes in just a little bit. Bread flour is a little bit further in, but again, basically the whole thing. Pastry flour now starts to come a little bit towards the center. And cake flour is processed just from the very, very center. So So have you ever gone to the grocery store and looked at the costs of these different specialty flours, cake flour, pastry flour? They're a lot of money compared to your bread flour and your all-purpose flour. The reason for that is because look how much you're getting from, and think about this, this wheat kernel is the size of my pinky nail. From in there, they're able to process the endosperm, and from that endosperm get to the very, very, very center of it, just to get the cake flour.
That is amazing.
Which is why it's so expensive, because it's taking so many wheat kernels just to get 1 pound of cake flour. That's crazy, right? But did you ever notice the color difference and the texture difference between all the different flours? Like that video that you guys watched last week. When you squeeze cake flour, it clumps in your hand. You can squeeze it and it stays together. Where bread flour, if you squeeze it, mostly, I think last week they put the wrong flour in the wrong bin, so usually if you squeeze bread flour together, it'll fall apart in your hand. It's not gonna really clump together that much. The reason for that, the higher the protein content, the lower the starch content. The lower the protein content, the higher the starch content. So when you squeeze flour and it clumps, it's the starch that's clumping together. The reason it's so white is because you're moving further and further to the center and further away from the bran that's on the outside as well as the germ. So you don't have that like tinge of color from the brown bran and the brown endosperm. So the further you get to the center, the whiter it's going to be. But also the more tender your product is. Because the protein content is so low, if I were to use cake flour in our bread recipes, you're never gonna get as tight of a gluten matrix as you would with bread flour because your glutenin and gliadin are at a lower percentage. In the reverse, I would not want to use bread flour for a cake because I don't want that tough texture. I don't want to be chomping on a cake for 5 minutes and then feel like I need to like chug a gallon of milk when I'm done eating it, right? You want it to have a very tender, light texture, which is why you would want to use cake flour or pastry flour so that you have a reduced gluten content. You still need the gluten to hold it together, but you just don't need as much of it and you don't need it to be super developed. Remember, the more you're mixing it, the more it's developing, okay? So for bread work, we want to mix through all 3 speeds to get that gluten development. We want that nice, tight texture. When you move into Bakeshop 2 and you start doing cakes, you want a looser gluten development because you don't want the texture of a bagel in a cake, right? But you also don't want the texture of a cake in a bagel, right? Basically, baking, it's all the same ingredients. It's just how you manipulate them. Now, what flour did I not mention where it's harvested? Nope, just from my white flours. Ignore semolina for now. All purpose. So where does all purpose come from? Whole wheat is the whole kernel. Your white flour is just from your endosperm.
Well, I mean like the red flour or the white.
These would be all white flours.
Right, okay.
Would it be fiber?
Nope. Nope. All purpose is a combination of bread flour, pastry flour, and cake flour.
Oh, so it's just like in the middle?
It's a mix. It was created in, I want to say, the 40s. Some businessman got this great idea that, hey, you know, all of these women at home that are, you know, waiting for their husbands in their little fluffy dresses and their aprons, waiting for their husbands to come home and serve them dinner, they're all making these cakes and cookies and breads and all this stuff because I'm Betty Homemaker and I need to impress him. So this businessman came up with this great idea that there's gonna make a flour that's all purpose. It gives you the best of all these worlds.
Okay.
So it's 50% bread flour, and 25% pastry, 25% cake. Somewhere around there. Each company has their own different, blend, but it's all purpose, meaning, look at the gluten content, it's 10%, around 10%. So this allows all-purpose flour to be used in breads, where it's still gonna form that nice, tight gluten matrix, but it can also be used in cakes and pastries and have that lighter texture that's not as developed. Now, it's not gonna give you the same result because the difference between 4% and 10% is still pretty big, but it's good enough for the non-professional to be able to, instead of going to the store or to the bakery and asking for a 5-pound bag of cake flour for $10 or whatever it is, we're gonna create a super cheap product called all-purpose flour where you just have to buy one flour and you can use it for all these different things. Professionally, I wouldn't recommend it. If you're gonna be selling the product, you want to have the right ingredient for the right job. However, for at home, it's fine.
Because it's like an average, it's just like a...
It's like an average.
conglomerate.
Exactly. It's the average protein percentage.
It'll work for, multiple persons.
It'll work for so many different things, which is why it's called all-purpose.
Ooh, no, I never knew.
Crazy, right? I wish I had thought of that. Bet that guy's rolling in the dough. Get it? In the dough. All right, so all-purpose is not necessarily harvested from a specific area in the endosperm. It is a combination of bread flour, cake flour, and pastry flour. So you can create your own all-purpose flour. Questions on this? All right, so your gluten matrix is formed by glutenin, gliadin, moisture, and mixing. Your glutenin and your gliadin are both found in your endosperm. Your endosperm has your protein and your starch. Your bran is the fiber, your germ is your healthy fats and vitamins A, C, and E. Whole wheat flour would be the whole kernel being processed. Okay? The higher the protein content, the lower the starch content. The lower the protein content, the higher the starch content. Yes, so all-purpose, I can't spell that. All-purpose is 50% bread flour, 25% cake flour, and 25% pastry flour.
So you said the lower the protein, the higher the starch content?
Yes. Questions on this? Does anyone want a picture before I erase? Oh, I can't take a picture on this.
I remember from that video, right? I didn't know she squeezed it and it held together. So it's really just a function of starch, obviously, right? There's just no obviously moisture in there, but it's just
Unless it absorbs it from
air.
the air. Yep. But in that video, she did add water. And then you could see, I think it was later on in the video, she pulled I think she did it with her spatula
she did that,
to
right.
see how the water absorption was in each of them.
Right, yeah.
Let's do, okay, so we did flours, we did gluten. Now let's talk about yeast. Okay, so we've touched on this a little bit throughout class and demos and stuff. So yeast is a microorganism that is living, it's alive, just like me and you. Microorganism. And there's different species of yeast. That grow in different situations and scenarios. So we have a microorganism that is kept alive with food and warmth. So for our purposes, there are 4 types of yeast that we need to talk about. Name me one.
Wild.
Usually no one guesses that one.
Like pandemic sourdough.
Dry yeast.
Dry yeast. Which one?
Active.
Active.
Fresh.
Instant.
Active. Instant.
Fresh.
And fresh. Good. So the one that you guys have been working with most in here has been the fresh yeast, just because that's my preference. I really like the flavor that fresh yeast gives to our doughs. I like that it's a little bit floral. You might have some recipes. I don't remember if today, if you guys use instant yeast.
It says today.
It is today, right? So these are the two.
Yeah, instant today.
That doesn't make any sense. These are the 2 types of yeast that you guys are going to be working with in this class, fresh and instant. Active dry is another type of dry yeast, but it's not as common to use because you have to activate it in warm water and look for the bubbles before you can continue with your production. Layla, you're too funny. I hate my handwriting. So active dry, you need to sprinkle over your water. Your warm water, always warm. So you want to sprinkle it over and look for bubbles. When you see those bubbles, that means that your yeast is alive. If you don't see bubbles, that means that your yeast is probably old and you're not going to get a lot of rise from your dough. So that's why we don't usually use it in the professional bake shop, because we don't have time to look for those bubbles. You know, this is a quick, I think, did I show your class the 12 steps of bread baking last week, the video?
Yeah.
I showed that to you guys. So you saw that guy that works that overnight shift? He doesn't have time to look for bubbles in his dough, right? So we usually use instant dry or fresh. Benefits of these are, again, like I said, I like the flavor that fresh gives to my doughs. I think it's like a little bit more unique. I think that it's more floral. But the downside of using fresh is the shelf life. So fresh could last, I mean, at your max, maybe 3 months. You could freeze it, but it's not gonna be, it's gonna be a little bit slimy when you take it out. Instant dry yeast does not have a very short shelf life. It has a much longer one. So you can throw it on your shelf for a year and not have to worry about it. And you can incorporate it into your dry ingredients. You don't have to put it into your water and wait for it to bubble and all of that nonsense. You can just put it in your dry ingredients and go to town with mixing it.
What's rapid rise?
Rapid rise would be active dry.
Yeah.
Yep.
Which I think some recipes discourage using that.
Yeah. I think sometimes they also call it bread machine yeast.
Okay.
Yeah, there's usually when I see a recipe that calls for those, I always have to do a Google search to see like what the heck they're talking about, you know, because the industry, the marketing calls it all kinds of different things. Okay. So what I want you guys to know is the difference in how we use these. So not just like you have to sprinkle it over water and look for the bubbles. That was just like a little tip that I find that most people ask me about. But for us, you can use the first 3 interchangeably. So fresh, active dry, and instant. Edward, I need you to stand up straight, please. You can use these interchangeably in a recipe. So if your recipe calls for instant, but you don't have instant, you can use fresh, but you have to do a little bit of math to figure it out. So for every 3, let me put it in a different color. For every 3 ounces of fresh yeast, you would use 2 ounces active dry and 1 ounce instant dry. So basically, if you were gonna go from fresh to instant, let's say your recipe calls for 6 ounces fresh, and you want to figure out how much instant yeast you need, you're going to divide it by 3. And that will give you 2 ounces of instant. So if it's active dry, then you're going to go from fresh to active dry, you multiply by 0.66.
Okay, but ordinarily you have to make this.
Yeah, so always pay attention to which one it's asking for.
Right, yeah, okay.
And some books won't tell you. In the beginning of the book, like when they go through, there's usually a chapter on like ingredients and tools and stuff like that. They'll make a disclaimer. All of the recipes in this book use instant yeast. So then when you look at the formulas, it doesn't say instant, fresh, active, it just says yeast. So if you're just looking at the formulas without reading the beginning of the book, you're like, which one are they talking about?
Because I guess if you don't make the adjustment, something might be a little wonky. Right?
Oh, yeah, it's not going to rise as much for sure. Or it'll rise too much. Yep. Okay, so what I need you guys to know is that your instant dry is going to be more concentrated than your fresh yeast. So think of it like the difference between a grape and a raisin. They come from the same fruit, right? A raisin is just a dehydrated grape. Same idea here. Your instant yeast is dehydrated fresh yeast. So they're just removing the moisture. Same with a grape. So when you eat a grape and when you eat a raisin, which one has more of a potent taste or more sugar in it? The raisin, because there's no moisture in it. Same idea here, which is why you're going to use less of it for the same recipe. Okay, because remember, fresh yeast is going to have moisture, so it's going to weigh more. So you need more of it to compensate for that extra moisture that's in it. Any questions at home?
Yeah, I have one question.
Yeah.
Say you didn't make, say it's calling for instant, and we just use fresh, there's more moisture in the fresh.
Mm-hmm.
So then what would happen with the product?
So if your recipe called for 1 ounce of instant and you used 1 ounce of fresh,
You don't have enough of
you won't have enough
Right.
rise.
that. Okay.
Yeah.
Right.
So your yeast is probably going to overfeed very quickly and will over ferment very quickly
Okay.
because there's a lot more sugar available to a small amount of yeast, so it's going to be like a feeding frenzy.
Yeah.
Yeah.
Okay.
Mm-hmm. Okay, so if there's no questions on these 3, now we can move to the most exciting part of the lecture, which is wild yeast. So where do I get wild yeast from? The air, the environment. So wild yeast, wild yeast is found everywhere. It is in the air. It's on your station top. It's on your hands. It's under your fingernails. It's everywhere. It's settling on everything. Okay? It's just a natural part of our environment. So when you guys are dissolving your yeast into your water, when you're doing your straight dough mixing method, I requested that you guys use your hands because there's wild yeast on your hands and you're promoting fermentation, okay? It sounds funky, but just stick with me, all right?
So professionally, they just use your hand.
Yeah. Unless they're making like a giant batch, which they might use a mixer for. So it depends on the size. So what does wild yeast look like? You can't see it, right? It's not like I'm like running around with a butterfly net trying to catch it. So what does wild yeast look like? Have you ever gone, I'll go to grapes again. Have you ever bought grapes at the grocery store? What do you look for when you're buying grapes?
No mold.
And the mold looks like what?
Little spores, like the little colored white.
The white coating on the outside of the grapes, right? That white coating is yeast. That's natural wild yeast from the atmosphere. That's what's left over from after they harvest.
But people don't harvest, they don't harvest that from fruits, do they? And use it in baking?
No, but in winemaking, they leave that on to promote the fermentation in the wine. So when you go to the grocery store and you look for grapes, most likely you're looking for the grapes that don't have the white coating on them, right? Have you ever tasted that white coating?
Yeah.
It's bitter, right? It kind of leaves like a powdery residue on your tongue. That's yeast. That's natural wild yeast. Now I'm going to tell you that you're all wrong. When you look for grapes, that's what's called a quality control factor. And you'll learn this when you take your purchasing class. Quality control factor. So when you are the boss and you're running a school or a restaurant or a bakery, and you're in charge of the purchasing orders and receiving the orders, you have to fill out a form that basically outlines in what condition you're going to accept all of your products. So, for example, flours. If I were in charge of purchasing, on my spec sheets, specification sheets, mine would say, I will not accept any bags of flour that are open, wet, leaking, any of that. So that when the delivery man comes and he tries to give me a bag of flour that's ripped open, I can pull out my spec sheet and say it's all in our agreement that I'm not accepting anything in that condition. You need to take it back and bring me a new one. So all of your items go through that. Part of those spec sheets are quality control factors. So what are you looking for in your produce or your chicken or your proteins or whatever it is? What are those visual factors or like smells, aromas, like stuff like that of what you won't accept? So for grapes, when I'm shopping for grapes, I want that white coating on the outside of them because it tells me that not a lot of people have handled the grapes. When you touch those grapes, that white coating comes off. So if you have grapes where all that white coating is gone, that means that 1 million people have handled your produce and they're probably going to go bad very quickly because they're probably bruised. People have squished them, passed them, dropped them. When the white coating is still on it, that means that their integrity is preserved. So you're getting a better produce that is going to last longer. When you get it home, you can wash it off. But you want that initial purchase to have that coating on it because it's a quality control factor, meaning I'm controlling what the quality is based on what it looks like. Same idea as strawberries. You're not going to buy strawberries that don't have bright green leaves or look like they're all bruised, right? You're not going to take them home because you know that they're going to go bad in 2 days. They're going to be molded at the bottom. Same idea as raspberries. When you select raspberries, you should be looking at it from the bottom. They put a red piece of matting in the bottom to trick you, to make you think that it's not leaking. But you don't want to buy raspberries that are leaking red, right? So that's wild yeast. That's that coating on the outside of the grapes, okay? Right now, I mean, I encourage you to wash that off, but when you're initially purchasing it, that's a quality control factor, okay? So why is wild yeast so important? Wild yeast is, like I said, this is found in the natural environment. Your first 3 up here, these are all commercial yeasts, meaning you can buy them. Commercially, you can find them in the grocery store. Okay, so those are commercial yeasts. Wild yeast is naturally found in the environment. You cannot buy it. But the really cool thing about natural yeast is it takes on the flavor of the environment that it's found in. That's called terroir. Terroir. I think there's an E. I think it's E. It's French. Means flavor of the soil or flavor of the region. This is popular in winemaking and in bread making. Both use fermentation. Okay, flavor of the soil or flavor of the region. So an example of this would be San Francisco. San Francisco makes a ton of sourdough breads. The reason for that is because San Francisco is located right on the West Coast, right? So the Pacific Ocean is there. And what do they also grow or make in California? Wine. They also have a lot of farms. So everything that has ever grown in the soil or anything that ever died that broke down in the soil, all of that stays there. And it is then, it gets rained on, right? And then it evaporates into the air, and the wild yeast takes on all of those flavors of everything that was in the soil. So when they're making sourdough bread in San Francisco, all of the yeast that takes on all those flavors is lending those flavors to the bread. So let's say that I'm a professional bread baker in San Francisco, and I make my sourdough starter. So sourdough starters, you begin usually with an equal part of flour and water, and you can keep them alive as long as you feed them and you allow them time to grow, and you just keep feeding them and you don't ever let them collapse. You can keep your sourdough, your starter or your culture alive for as long as you keep feeding it. I've worked with sourdough cultures that have been 400 years old. Okay, so sourdough starters, as long as you feed them, you can keep them alive forever. These are also called mother doughs or pre-ferments. So, okay, so sourdough starters, if you're using them often, then you want to feed them once a day. If you're not using them, you can put them in the refrigerator and just feed them every once in a while. Refrigeration is going to slow down your fermentation, okay? If you don't use them for a really, really long time, you can freeze them. So I always say that it's best to keep like an emergency reserve of starter in your freezer, just in case something goes wrong. Okay, so let's say I'm a sourdough bread baker in San Francisco. I have my sour, I've had it there for 8 years. I use it every day in my bread making. So your amount that you keep should be big enough that you can use a portion of it in your bread and then have a portion of it that you can feed. Then it rises overnight, and then you do the same process. Use a portion of it in your dough, feed the other part, let it rise overnight, and you just keep doing that. My starters I keep in the fridge because I don't use it every day. We only use it every once in a while. So I only keep a very, very small amount just so that I can get it growing if I need to make a large amount. So you would just increase your feedings. Now, depending on how warm it is, you may have to feed several times a day, or during the winter, you only feed once a day. Depending on how humid it is, how high the temperature is, the temperature of your flour, because warmth promotes fermentation. So the warmer it is, the faster your yeast is going to feed, the faster it's going to run out of sugar or food from your carbohydrates. So then you would have to feed more often. Or if you wanted to try to control the temperature a little bit, put it in the refrigerator in between feedings, and it will, extend the amount of time between each feeding. Different acids are created at different temperatures. Don't quote me on this, but I think in the refrigerator it creates lactic acid. At room temperature, it creates acetic acid. I'm not going to test you guys on this, but just for people that are curious. So lactic acid and acetic acid are the two acids, or the two flavors that are created during fermentation. Most sourdoughs spend some time in the refrigerator and some time at room temp, so that different bakers can manipulate and control what flavors they want. Some sourdough bakers give them a 24-hour fermentation. Basically, instead of proofing in the proof box, they would, it's called retarding in the refrigerator. Retarding, it comes from the Italian musical term ritardando, meaning to slow down. So retarding always happens at a cooler temperature so that it slows down how quickly the yeast is feeding. Most sourdoughs will spend about 24 hours in the refrigerator. Instead of proofing, they retard them in the fridge overnight and then bake them the next day.
Wait, so lactic is formed, what?
Lactic is the fridge,
Fridge.
acetic is room temp, I think. Okay, so let's say I'm a sourdough bread baker. I've had my sour for 8 years. I use it every day in production. Oh, sorry, I forgot my microphone was there. Yes, so refrigeration slows down fermentation. Okay, so I'm in San Francisco. I use my sourdough starter every day, and I get a job opportunity to open a bakery in New York, which, by the way, those jobs exist where like you're only the person that opens restaurants or bakeries, and you literally jump from state to state just to get the restaurant or the bakery like on their feet. You stay for like 3 months, and then once they're like good on their own, you move to the next one. So just putting that out there for those of you who want to travel. So I get a job opportunity in New York, and I pack up all my things. I move to New York to open the bakery, and I bring my sourdough starter with me. It survives the plane ride, it survives the whatever, cross-country road trip. I get to New York, I start feeding it the flour here, as well as the water. The flavor that my breads are gonna come out with are gonna be drastically different than what my breads tasted like in San Francisco, based on the terroir, or the flavor of the region. Do you guys know what the largest agricultural product is that we grow in New Jersey? Aside from plants, aside from like flowers.
Tomatoes.
Actually, not tomatoes.
What's the largest thing?
Largest agricultural product. Anyone at home? Not corn, close. Well, actually, not really close. Good guess, though.
And we'll find it at the farmer's market?
You'll find it at the farmer's market for sure.
Lettuce?
Nope. Think berries.
Oh, cranberries?
Cranberries.
Yeah.
Cranberries are the largest agricultural product that we grow in New Jersey, and almost tied would be blueberries. So now, since that's what's growing in our area, our bread or our yeast is going to start to take on all kinds of those different flavors, different from what they grow in California. And depending on what region in that state you are feeding, like if I feed my sour here and then I take it home to Pequannock in the boonies where I live, it's going to taste totally different if I feed it at home than if I feed it here, because my water is different. I have different minerals in my water at home than you have here. Okay, so terroir means flavor of the region or soil. Same idea with winemaking. That's why wines from different regions in France taste so good, because those countries are so old, and you know what they have in their soil?
Mold.
Dead bodies. It's true. Think about all the wars that were fought. There's lots of soldiers that are breaking down in that soil. So different areas will have different flavors in their soil. And your agricultural products, wine is an agricultural product, takes on those flavors. basically. Any questions about wild yeast, where it's found, anything at home? Nothing.
Very interesting.
Interesting, right?
So I guess that's why if you go to buy a bread, and currently Trader Joe's has this, they'll have sourdough, but then they specifically have San Francisco sourdough.
Yeah, because it's totally different flavors.
With use there, that,
Yeah, I took a week-long class at the San Francisco Baking Institute last summer. Oh my God, if you ever have the opportunity to do it, you gotta do it.
What was that, like a couple $1,000 or expensive?
The school paid for it. It was part of my tenure.
Oh, that was good.
Yeah.
It was a good class.
Oh my God, it was amazing. Absolutely amazing. I mean, you work your butt off for sure. For sure. When I came back, my dean was like, so did you like get to go to like any of the restaurants at night? I was like, are you kidding me? Like when I got home from class, I was exhausted. Like I ate dinner and went to bed and woke up the next day and did it all again. Like it's a long class. It's like 8 or 9 hours. And but they like serve you breakfast and it's all the stuff that they've made in their different classes. So I was taking a viennoiserie class, which is like croissants, Danish, brioche, stuff like that. But the class that was in the bake shop next to me, they were doing all lean doughs, baguettes, and so we would trade. They would bring us over baguettes because by the time you get to like day 5, you're like, oh my God, I'm tired of croissants. Like this is like getting crazy, you know? So we would trade each other at the end of the day.
What a nice experience.
It was a really, really great experience. But they offer, and they're doing online classes right now.
Okay. My daughter lives there, but she's getting really into cooking. She lives there.
It's amazing. Yeah. It's the classes they have like some are like 5-day classes, sometimes they're 2-day classes, like there's all different ones.
She always wants to, go out there and take a class somewhere with her, and there's a lot of options in San Francisco.
Yeah, they're great. And on Fridays they serve you wine with lunch.
All right, that's good.
So I think that the question here is wild yeast is found in the environment. So you can't buy wild yeast. Okay, so up here, fresh, active, and instant, these are called commercial yeasts. You can buy them at grocery stores. Wild yeast is collected from the air. So when you make a sourdough starter, you're mixing your flour and your water, or if you were to make like a really quick pre-ferment, basically it's a dough that ferments overnight and you use it in your dough the following day. It's just collecting the wild yeast from the air. You mix it and let it sit at room temperature and the yeast that's in the air will settle inside of it. There's also yeast in the flour, just from natural harvesting. Now, in Europe, they have different food laws than we have. So they take their, what would you call it? Like labeling, like their version of the FDA is a lot more strict with, like how I was saying, a rye has to be 30%. In Europe, you can't call something rye bread if it's not 30% rye flour. You're not allowed to, it's illegal. Same thing with pizza. Like pizza has certain requirements that it has to meet for it to be called pizza. Wine has to meet certain standards of like additives, preservatives, like stuff like that in order for it to be sold. Same with breads. In the US, the people that are in charge of monitoring like the different stuff that companies are adding to their wines or their breads or how they're processing flours and stuff like that, the division that's in charge of that is the same division that's in charge of terrorism. So you could see where on their list of priorities flour is compared to, bombs. In Europe, it's different. So their version of the FDA, they take it like really, really crazy seriously. So when they process flour in Europe, it's illegal to put it through the different chemical processes that we do in the US. So if you look at flours, you'll see that they're like bleached or brominated, stuff like that. The reason that they do that is to, one, make the color white, because Americans like white bread, right? It's all about marketing here. So they bleach the bread so that it doesn't have any of the I was going to point to the endosperm, to my wheat kernel. It doesn't have like any residual, coloring from the fiber and from the bran or anything. But they also want to kill like any microorganisms that might be left in the flour because it's a natural product that's being harvested from the environment. The problem with doing that is as they're putting it through these different processes, it's killing all the good stuff that's in it, like the wild yeast. So in Europe, because their flours are not processed like ours are, they have to use far less commercial yeast in their recipes than we do. You'll often find that breads in the US, you can taste like the commercial yeast. Like once you kind of know what that's supposed to taste like, you can taste it. It's like, oh, this doesn't necessarily taste like bread or fermentation, it just tastes like straight up yeast. And that's because we have to add more yeast to our formulas to compensate for what they're destroying when our flour goes through that process, which is why I like King Arthur. King Arthur flour does not put their flours through the same process as like Pillsbury and stuff like that. There was also a huge movement a couple years ago for bread shops to refine their own flours. So there was a huge, and I mean, it's still happening now, but this was like a big fad probably like 6 years ago, where farmers were pairing with genetic scientists who were also pairing with bread bakers to figure out what the best features were of different types of wheat kernels and figuring out how to breed plants specifically with those qualities, so that they could do it, so that the farmers could grow them based on what the genetic researchers found, and then the bakers could use those flours that they harvested and process them in their own bakery so that they didn't have to bleach all of the microorganisms out. And basically kill all the good stuff along with the bad stuff. So if you go and look at like artisan bakeries, if they're milling their own flour, they're like damn proud of it. They'll put it, I mean, everywhere. And you can go back and see like their little milling process and the different hoppers.
Do you use these flours and mills around here?
Chef Lontalk does in the advanced breads classes. That's where they really start to get into. Yeah, but there's actually, we hosted a class here for the Bread Bakers Guild, and one of the guys that came was a miller. What company was he from? They sponsored the class, so like they brought all of the flours from this like very small mill. So I have worked with the flours, but I'm working on trying to get like different mills to sponsor us, but it's, then COVID happened, so that was but yeah, I would recommend if you could get flours from these small milling places, for sure, they're better quality. And you would have to use less yeast because there's more wild microorganisms in that flour.
So you just have to, in that ratio, you just have to figure out.
Yeah, you just play with it.
Yeah.
Yep.
That's really interesting.
Any questions at home? All right, so that wraps it up for today for lecture.